All right, what's going on, y'all? Back with another video. How to take a break over the weekend. Today's Tuesday. We have about 9 days. Let's jump straight into this review. So where I left off was doing, I believe it was a QADT. A lot of these questions I wasn't able to answer or didn't have the chance to answer these. So I'll have to come back to them and let you guys know when I get to some solution for these. Uh, Here we go again. Forgot. You guys can see these. So this was on, um, this was on the stacking queues, and I asked if anybody knew the actual the questions. So these are the questions here. Indicated on stack. Yada yada yada. 1, 2, 3, 4, 5, 6. So in total, about 6 questions. If you guys are able to answer any of these or solve any of these, just let me know. But I'm going on today to move to our next section, which is linked lists. So over the weekend, I was doing linked lists since I couldn't answer these fully. So I just decided, like, hey, let me just not waste my time trying to solve these and then just, focus on linked lists so I could get you guys to where you guys need to be for the exam. So that's what we're going to do today. We're just going to go over linked lists. I'll do all this editing after. I was going to highlight these red, like so, like that. But yeah, that just reminds me to come back to these questions. So I guess let me do it now. But hopefully everybody's weekend was good. Um, I had a nice break, prepare myself mentally for the exam. Um, it's a tough one. It's not like it's some easy exam. It's not like, oh yeah, it's like, these answers are just come to you and, you'll be ready and, you're going to need to study a lot. And the answers will come to you. It's like either you know the stuff or you don't. The professor's fair in that regard and also fair as to, what he expects from us. So, on top of that, we had like a pretty like rough semester as far as trying to know this material. Um, but for those that studied and feel confident, you guys should be well okay. You guys should be okay and just do great on the exam. For those that didn't study, it's going to be hard. These videos will help. They give you like some type of clue of like what to, like aim and like potentially like where I should be aiming at to study, and they should help. Like these videos should help. All I need to do is get through binary search tree, and I'll do heaps as well, just to be prepared for anything. But definitely not graphs. Graphs won't be on the test, and we don't know what he might put on the test, but you just got to be prepared for it all. Anyways, let's move on to linked lists. This is linked lists. This is what I've been doing for the weekend. It's been going over linked lists and all of his questions. Let me zoom in a bit. Um, these are the linked list questions. Like I said, I color code things just to identify the questions to answer together, and then the other ones, you could answer at another time. So yellow, all the yellow ones are like first priority. Like that's the one I usually go for. Green is second, blue third, purple is last. So that's how I tackle these. And let's move on to the code and let's move on to the actual problems. All right, so these are all our insert before and insert after statements. These are the questions. So this is one of them that says code an insert before and an insert after method for a linked list. You could decide whether or not to use dummy nodes. Draw a picture of what the linked list looks like when it's empty. So this is the code of insert before and insert after. Insert before being this one. Insert after being this one. I decided to use dummy nodes, so the lines of code are way less. If I didn't use dummy nodes, like you could just add on like 2 more lines of code each to both of these, but I chose dummy nodes. Here's a diagram of it. Yeah. So it has to do again, right? Insert before, after methods indicate whether or not you depend on the use of dummy nodes for the structured code to work correctly. So here's the code again: insert before, insert after with dummy nodes. This is my indication of my code, and this implementation of a linked list structure, the use of dummy nodes is dependent on for our code to work correctly, because dummy nodes would eliminate special cases. Those special cases being inserted into an empty linked list, inserting before head, and inserting after tail. So I'm not like we went through in class. You have head and tail. Dummy nodes get rid of having to insert before head and after tail, and turn into empty linked lists. If I scroll down, hopefully I have the picture of how it would look like. This is how it would look like without, dummy nodes. So you have head, previous, current, tail. So it eliminates having to insert over here and insert over here, and just gets rid of that case. So you'll just insert straight into the dummy node, and anything that does pop up, it just pops into that place as the dummy node for a reference. Next is moving on from this question to the next one. Insert, right insert before, insert after. You decide whether to or not to use dummy nodes, draw a diagram. So as you can see, this is a question that he likes to ask. So I would be prepared to answer this on the exam. I'll keep going. This is the code. I'll provide you guys with the code on my, whatever it is, Dropbox. On my Dropbox, I'll probably provide you guys with the code, and at the end of this, like, I'll provide you guys with all my documents and stuff. Like, I'll create a whole zip file and all the documents. You like just looking at this, like, I'll provide you with all that. Right, insert before, insert after methods, linked list. You decide whether or not to use dummy nodes. So once again, he's asking the same exact question. He wants it's the reason why he's asking you this. It's like he wants you to know this. So hint, hint. So be able to understand this, and explain like what you're doing, and like how this works. So here's another one. I wasn't able to answer this part of it. Sorry, y'all. But in each one of them, each one of these like different sections that I split it up to are the highlights. I believe I didn't answer 3 of them, 1 per each one of those, except for one of them. I think I was able to solve. So draw 2 diagrams represent an empty linked list. One with and one without dummy nodes. Right is empty functions for both of these versions of the empty list. So here's part A, with no dummy nodes, and it is empty function. So you have a head, previous, current, tail. They all have references, botches. They have references. So this is head, this is previous, this is current, this is tail. This is empty function. Public boolean is empty. Return head if it's null, and current null, and tail null. If they're all null, it returns it's empty, it's true. If not, false. Without dummy nodes, and it's empty function. This should be with dummy nodes. And it's empty function. So you have head, previous, dummy node, points to the dummy node. Public boolean is empty. This is empty code. Return size equal 0. If there's nothing there, just return that is true. That's it. So write an insert method and that inserts a value into the list at a given index position. And at the last position of the index and if, yeah, it should be if the index is beyond the length, okay. So write an insert method. Last position if the index is beyond that. Okay, so this was asked on the fall 19 test A. So we're in spring 2020. So if anybody's able to solve this, please, you probably want to be able to solve this. And then if you can, if you would like to, you could share with us to let us know that, you know, you solved this and this is how to solve it. I was unable to solve this, but this is probably a question you'll see on the exam. I guarantee you, like, this will be on the exam. Whether it's the exam, this exam, the test, or the final, you're going to see this question. You could do well with answering just this part, you know, like that's great, but that's only like 10 points out of 20. And who knows how you might ask this. It's like each question may be worth 30 points, you know, or 35 points. So, you know, it'd be great if somebody could help us solve that. So the next one, write an insert before after methods for a linked list with dummy nodes. So this is that, and that's it. So it's just the same insert before and insert after. I use dummy nodes for a linked list with and without dummy nodes. Okay, so my bad. Let me just do this really fast. I'll have to come back and I'll have to do this with dummy nodes and without the dummy nodes. So I'll come back and I'll do that. Just bear with me because I was doing this at nighttime when, you know, I wasn't really even paying attention to that part. I just totally missed it. Sorry, y'all. But I have to answer that question. And yeah, so that's the first part. Let's go straight to number 2. These are the codes. I'll give them to y'all. Number 2, I'm no expert, by the way. This is not an expert tutorial to pass in CMP338. This is just me trying to wrap my mind around what I'm going to be facing, and hopefully this helps you guys. So this is number 2. This one has like the most unanswered questions. So I think what I was trying to get at here was deletion, removing, and linked lists of queues. So yeah, so in a linked list implementation of a queue that we did in class, there were 2 distinct structures that we decided on to would both represent an empty queue. Draw a diagram of each and explain why we decided both would be considered an empty queue. I'll come back to that. I'll answer that sometime. But I left that blank for now. Write the delete method for a linked list. Can y'all tell me if I got this right? You decide whether or not to use dummy nodes. So I believe I use no dummy nodes, public void remove if previous .nets equals head, previous .head. And that's basically like the function to remove it, and then previous .nets equals previous .nets nets. It moves it to this part right here, moves it to the nets iteration. So I use dummy nodes. Could y'all let me know if I got this right? Thanks, appreciate y'all. In the linked list implementation of class, hint, we use 2 distinct structures, hint, you see this before, hint, we did this before, hint. Write the delete method for a linked list. You can decide whether or not to use dummy nodes, same code as we did before. Be looked out there, guys. Hint. Write a remove method that both locates and removes the node containing a given int from a linked list structure implementation of a list of is. Oh God. This function does not remove the current node, nor is the node removed based upon its index. It is removed based upon its value. I'm hoping you guys can read more than like I have to read to you guys. And you guys see the question. I don't know if this code is right. This is just code that I put in there and that I hope is right. So publish static void, delete node in this key, node temp equals head, previous equals no. If temp is equal to no, and temp dot data is equal to key, head equals temp dot nets, return that. While loop, while temp is no, temp dot data is key, previous equals temp, temp equals temp dot net. So iterate and move up. If temp equals null, return it at previous dot nets equals temp dot nets, replace it. All right, so that's just the code for that. You could use that. I'll provide you guys with the code in here. I'm sorry if I sound exhausted. It's because I did this and it was just tiring just looking for all the answers, and it took me like 3 days just to get linked list done. So like it was just, I was just exhausted at that point. I don't even know what these are. Let me see really fast. Yeah, so I'm over here like I don't even know what I'm doing. Like I just hope that you guys are a little bit more at ease after seeing some of the answers. Oh God, Christ. Number 3. Change some order. So this is blue ones now. Code the push and pop methods of a stack of integers. So I think this one I was able to solve, no, not everything, but a good majority though. Yeah, so push and pops, da da da. Everything's here. Like I'll provide you guys with the forms. I realized I should just like, you know, if you guys look at it, everything's right here where the questions appeared on, where they come from. Like if faster, you could just look at here. Yeah, man. So let's go. Code the push and pop methods of a stack of integers implemented using a linked list structure. Push method is this. Pop method is this. Public void push and ets. Top equals new node ets. Top. Public void pop. Top equals top dot nuts. Given a sorted linked list, code a method that would insert the nets value in the correct position to keep the list sorted. This is the best code I could find for it. Public void insert and value, previous equal head, whole previous dot nets, that's less than or equal to a value, previous equal previous dot nets equals new node, value previous dot nets. Tell me if we could even use whole. I use whole. Let me know if this code is right or not. I don't know. Good luck, everybody. Write the push and pop methods of a stack of integers. Push, pop, we did it before, just a while ago. That's that. Write the push, pop methods of a stack of integers. Push, pop, here we go again. Given 2 linked lists that each have references into the link structure for head and tail only, write the code that concatenates the 2 linked lists into a single linked list. That I did not know. It's a good question, Professor Murphy. Did not know that. If anybody could figure out that code, you know, we're paying top dollar to figure that out. And I hope you guys mind if I pay you in fake currency. So this is another one, the insert code. We did it before. Oh, for this question, it's probably going to be on the test. This is like one of those more involved questions where he'll ask you this and see like who's the really smart ones in the class. I'm not that. So if you're able to solve this, pat yourself on the back. Probably you're gonna remember it for the exam, you know, and hook us up. Uh, let me see. Yeah, so push and pop methods. Here we go again. Push and pop methods. Here we go again. Hint, hint. That's about it. I mean, I I think he might add some push and pop methods on one of the sides for this exam because it's so easy of a question. But then he'll give you something where it's just like this, or something where it's like more involved, such as this, or something even harder. Like he doesn't want to give you those like what like on the test. He doesn't want to give you those like points where it's just like, oh yeah, it's free points. It's never free points. It's like either you get 10 out of 20 or you get 8 out of 20 or something like that. It's just like you need to know both parts of the question because that 8 out of 20 could turn into 16 out of 20 if you're able to solve both parts to some type of degree. And that's really where you get your points from. It's just knowing both parts of the problem. So like, okay, he'll say like write the push and pop methods of a stack. Yeah, we know that. But now write the insert and before methods of a linked list, which we went over. And then should we use dummy nodes, which are in a linked list implementation of a stack? Why or why not? So like these are how involved the questions are. They're not like necessarily like, okay, you got to solve the question over and over again. It's like you should study to know all parts of these questions and like have it in your brain. Like, okay, in linked list, I know potentially he could answer the multitude of push and pop methods, delete methods, remove methods, and then a general question where he'll ask you about dummy nodes and their importance to linked lists. These are more the questions that he's been asking through like the summertime. I remember seeing these. Um, they're pretty chill. Like the finals questions were pretty chill, and the finals questions again were like really chill. But even still, like if you prepare for like test A and test B, and you go in there and go like, okay, like I'm going to be prepared. Like I said, it's just here's one of them. Remember, I said like we're looking at get you paid if you know this question. The imaginary money, of course. Um, and here's the other question. Um, there are two distinct structures. So like both of these questions I wasn't able to answer. But I did get the other parts. So I mean that's like 10 points if I got it right. Um 8 points if I didn't, 5 points if I didn't. But then like imagine like I'm able to show like some type of clue what I'm talking about. Then another 5 points or 8 points goes a long way into like doing well on the exam. And remember he does it by section. So when you come into the summer 19, if you got like between these two questions, you got like let's say you got a 10, like you need to ace this whole part. Like you can't just go, oh, I'm gonna just get push and pop methods, and then I forgot my insert before and after methods. Um, and expect to get like full credit. Like he'll go like, no, you got 10 over here, you got like 11. I'll give you the 11. But what happens if you get 9 on this and you have 10 on this? Like you just study like a whole lot just to get the same amount of points that you did before, and it's just like coming to the test prepared is the just what I'm saying. At least like do yourself a favor and like use every resource. Like use me as a resource. Like trying to go through here and present you with everything possible. Oh man, we're on the last of the questions from link list. Was I able to solve everything here? No, again, I wasn't. So yeah, so you'll see like I'm not able to solve everything, but I'm trying to solve everything for you guys. Um, please, like I said, if you know any of these answers, hook a brother up, man. I'm trying my best, y'all. All right. Should we use dummy nodes in a linked list implementation of a stack? Why or why not? My best guess is we should not use dummy nodes in the linked list implementation of a stack because if we did have head, it would be where we would push and pop from, and head would constantly be changing. I don't know if that made sense to you, but yeah, I'm not gonna. I'm just gonna read again. We should not use dummy nodes in the linked list implementation of a stack, because if we did head, if we did use head, it would be where we push and pop from, and head would constantly be changing. In our linked list, I'm moving on to the next question. In our linked list implementation, where a dummy node is used, what was the purpose of the dummy nodes? Draw a diagram of the empty linked list with one dummy node. In a linked list implementation, the purpose of having dummy nodes is to eliminate special cases. We talked about this before. These special cases are inserted into empty linked lists, inserted before head, and inserted after tail. This is what it looks like. This is a diagram of an empty linked list with one dummy node. Okay. In our linked list implementation where a dummy node was used, what is the purpose of the dummy nodes? How dramatic was the change when we wrote with dummy nodes versus when we wrote with code without dummy nodes? Draw a diagram of the empty linked list with one dummy node. Draw a diagram of the empty linked list with two dummy nodes. In this last drawing, can you have a current reference, or you can get or can you get by without it? Why is this so? Which is preferred, and why is it preferred? Okay, so I wasn't able to answer that second part. Like I said, imaginary money is waiting for you. I got it right here. I got a whole stack of it. Got a big old stack of imaginary, a pallet full of imaginary money. If you're able to solve that second part. In a linked list implementation, the purpose of having dummy nodes is to eliminate special cases we may encounter. These special cases are inserted into an empty linked list, inserted before head, and inserted after tail. It is a very dramatic change from the code that we wrote with dummy nodes to the code without the dummy nodes. Here's a dramatic diagram with one dummy node. And I don't have the second part, I apologize. Oh, why is it dramatic? It's dramatic because like he may ask, like he's probably looking for more. It's dramatic because it's more dynamic. Dynamic. That's it. That's why it's dramatic, because the version with dummy nodes is more dynamic. Dynamic, italicized. Explain the purpose of dummy nodes and how they accomplish that purpose. So this is based off of given two linked lists that each have references to linked list structure for head and tail only. Write the code that can concatenates the two linked lists into a single linked list. That's why I put this in red, because I didn't get to explain the purpose of the dummy nodes and how they accomplish the purpose, because I didn't do the code. Should we use dummy nodes in a linked list implementation of a stack? Why or why not? So this is important. I've highlighted this green. Well, not that part, but this part right here. I guess it's all important. In a linked list implementation of stat, the purpose of having dummy nodes is to eliminate special cases we may encounter. These special cases are inserted into empty linked lists, inserted before head, and inserted after tail. We should not use dummy nodes in the linked list implementation of a stack. I'll repeat it. We should not use dummy nodes in the linked list implementation of a stack, because if we had head, it would be if we did have head. I'll put have there. Sorry for the wordage. We should not use dummy nodes in the linked list implementation of a stat because if we did have head, it would be where we push and pop from, and head would constantly be changing. We did this once before. That's the end of linked list. Those are all the questions. There's no code for that last one. Here is my thoughts on linked lists. If you broke down this section into different parts, understand the different parts, what's being asked, you could do pretty well. If you guys are able to solve those quote unquote cases I didn't answer, it's automatic 15 points. If you just look at the code I have there, like you'll get 15 points regardless. Like if you're really good, like if you're a smart like student, like one of those students where it's just like, okay, you know, I know what I'm doing. I don't. That's me. But if you're one of those students where it's like, I know what I'm doing, like I should be straight. Like you should be able to get 15 in this section just by the code like that was provided there. It'd be the same code like my key would kind of go over in class for the review, but there's no review. He's just like, is there any questions? And then he'll go over the questions that people ask. And I mean, like when the time is up, the time is up, and he'll say good luck and good luck on the exam, and that's it. Like this is your chance now to talk amongst us and ask us questions and whatever you may have. I'm not perfect. This is just what I have. This is everything. Um, hopefully this helps. This is the end of linked list. I'll show you what I have to go through for a binary search tree right now. This is binary search tree. Here it is. Binary search tree is a doozy. I'm sorry. It's going to take a lot longer than linked list did. But I'll get into binary search tree now. I'm hoping I have it done in the next 2, 3, maybe 4 days. Be patient with me. I'm currently at work remotely, but I have some time now since school is very slow now. Everybody's coming to the close of the year. Everything's slowing down at at my job, and I just want to help you guys out once again. As much as I can. Once again, we go by the same list: yellow, then green, then blue, then purple, and we got a new guy, navy blue, navy. So yellow, green, Cheyenne, purple, blue. Okay. All right, y'all. Good luck. Good luck in the studies. Hopefully, linked list helped y'all. I'll post up the code now. Put the link in the YouTube description. Yada yada yada. See you guys later. It's been fun. Oh, happy Cinco de Mayo. It's the 5th of May right now. Happy Cinco de Mayo. Yeah. Peace.